If you can't picture how Windows boots, you'll always be guessing when a machine won't start. In this lesson, we trace the boot sequence end to end, decode the registry control sets that decide which configuration runs, and learn to read a driver's start type so you can predict whether a fault is a no-boot or just a nuisance. To diagnose a machine that never reaches the desktop, you must know the order things happen. UEFI firmware hands off to the Windows Boot Manager. The Boot Manager reads the BCD store and starts the OS loader, which pulls in the kernel, the hardware abstraction layer, and every boot start driver. Then the kernel starts Session Manager, smss.exe, the first user mode process, which eventually leads to WinLogon and your desktop. Here's the practical payoff. If a machine hangs on the spinner before the logon screen, the fault is almost always before SMSS, a boot or system driver. If it reaches the logon screen and then falls over, you're in user mode service territory. SMSS is the bridge from kernel initialization to user sessions, so knowing which side of it failed instantly narrows your search. The live configuration lives under HKLM SYSTEM. Windows keeps several numbered control sets and records, which under the select key current, failed, and LastKnownGood. The crucial detail, LastKnownGood is only promoted to the current set after a successful interactive logon. That's exactly why LastKnownGood configuration can recover a machine a bad driver just broke. It rolls back to the set that last reached the desktop. Every driver has two numbers that predict its blast radius. Start type says when it loads, 0 is boot, 1 is system, 2 is auto, 3 is demand, 4 is disabled. ErrorControl says what happens if it fails, 0 ignore, up to 3 critical. A boot start driver with critical error control that fails will bug check or force a LastKnownGood rollback. A demand start driver that fails usually only breaks the feature that needed it. Read those two numbers with getItem property and you know whether you're facing a no-boot or a nuisance. Services start in dependency order under the Service Control Manager. If Service A lists Service B in its depend on service value and B fails, the SCM simply refuses to start A. One failed low-level service can cascade into a dozen downstream errors. So always trace upstream to the first thing that broke, not the loudest error in the log. Use sc.exeqc to dump a services config, and get service with -dependent services to see what relies on it. When you need to see everything configured to run at boot and logon, reach for autoruns from sysinternals. It enumerates every autostart location, drivers, services, run keys, scheduled tasks, codecs, and verifies digital signatures, so an unsigned or unexpected driver loading early jumps right out. Pair it with the diagnostics performance operational log, pulled with getWin event, to see boot timing events. Finally, learn to tell a kernel mode driver fault from a user mode service failure by how the machine dies. A kernel mode driver fault typically bug checks the whole system, often before you ever reach the desktop. A user mode service failure logs an error and the desktop usually survives. The crash style tells you which world you're in, and that decides whether you'll need a kernel debugger next lesson, or just the Service Control Manager. Recap. The boot order firmware, boot manager, loader, kernel, SMSS, WinLogon tells you which layer failed. The select key shows which control set is current versus LastKnownGood. A driver's start type and error control predict whether its failure is a no-boot or a nuisance. Your task, on a test VM, read the select key, pick 3 drivers and predict their boot impact from start and error control, run autoruns and find an unsigned entry, then map a multi-dependency services chain with SCQC and get service. See you in Lesson 3.